action begins down in the mine, where geologists point a niton gun at various spots in the rock face. The device detects the levels of 40 different elements, including silver. Silver in its natural state isn't silver-colored at all. It's charcoal grey. Those silver-looking deposits are actually zinc and lead. Miners drill holes in the silver-rich areas the geologists pinpointed, then insert sticks of dynamite. After the blast, carts haul the chunks of rock, called ore, to the surface. Geologists then test the piles of ore and blend them to achieve a consistent amount of silver content per kilogram of ore. The ore first goes into the primary crusher. The machine's huge steel teeth break up the chunks into smaller pieces. Those pieces then drop through the grates below into the secondary crusher, which breaks them down into even smaller pieces. Those go into vibrating cone crushers, which pulverize them into tiny pieces. A conveyor transports the crushed ore to the ball mill. At this point, the ore pieces are roughly 6 millimeters big. As the mill's large cylinders rotate, steel balls bounce around inside, grinding the ore into a powder. A water circulation system flushes the silver-rich powder out of the cylinder and into large tanks which keep the water moving. To separate and dissolve the metals in the powder, workers pour in acid. After 72 hours, the rock waste has settled at the bottom, and the solution containing dissolved silver is pumped through filter presses. The filter plates are treated with a zinc-based chemical which attracts silver molecules. As the solution passes through, the plates trap particles containing silver, forming a layer of black powder called silver precipitate, which is approximately 50% silver and 50% waste. To separate the silver from the waste, they first dry the precipitate in a gas furnace for a couple of hours. In the mining company's lab, technicians continually test ore samples to determine the grade, the term for the quality of silver per kilogram of ore. They heat the samples to 1093 degrees Celsius for about an hour to burn off the impurities. What's left after the burn-off are the silver and other metals, such as lead, zinc, copper, selenium, and cadmium. Lab technicians then treat the samples with a chemical that prevents silver from burning off and put them back in the oven. When the samples come out, about an hour later, all the other metals have burnt off and only silver is left. They weigh the silver and compare it to the weight of the original sample in order to calculate the grade. Once satisfied with the grade, the batch is approved and the process can continue on an industrial scale. So back at the mill, workers put the dried silver precipitate into an oven, along with the chemicals that prevent the silver from burning off. Approximately 4 hours later, the silver and waste have separated and melted. Workers pour them into bar-shaped molds. The silver is heavier and settles at the bottom. Workers skim off the waste, floating on top. In less than 5 minutes, the molten silver cools and hardens, and workers extract what is now a silver bar. The mining company sells the bars to a refinery for processing. So digging for dirt really can have a silver lining.